Hi, and welcome to the latest segment of LDG TV. I'm your host, Mark Miner, and we're here today with two of our brethren from the Linnetz office, Quentin Risler and Ryan Stauffer, who have both been involved in a very innovative project for LDG that's getting a lot of public attention. The bridge slide that you designed for our client RoadCon. Quentin, Ryan, tell us more about that and tell us about the innovation. I think there's a lot of innovation that happens at LDG regularly that we don't really realize is going on here.
Absolutely, yeah. We were very fortunate and very pleased to be part of this project. We've actually started before this project because we've been working with RoadCon for, I've been working with them for over 12 years now.
Wow.
So we've developed a teamwork and a trust, and so it was natural that we worked together in this project. It's not unusual to replace 2 turnpike bridges in a year. The unusual part and what required innovation was they were only allowed to close the turnpike for 1 weekend for 55 hours. So they had some ideas, but we helped them put together how we're going to do this. How we're going to replace that bridge in that 55-hour time period.
And there were some pretty significant penalties for not completing that.
Absolutely, the penalty was $55,000 an hour.
An hour.
For not, or any part thereof, actually, which makes it even worse.
Right.
So we focused on a couple things with them. One was simplicity. How can we make this as simple as we can? Because you can't have breakdowns. And how can we were able to find some work to move out of that 55-hour window, so that you have more time, more leeway.
A little extra time.
So the basic plan was to build the bridge ahead of time, beside the existing bridge.
Yes.
And then roll it into place in that 55 hours.
So tell us about the innovation that it took to do that.
Absolutely, and actually Ryan here is going to talk. Ryan led the design on this project, and he'll talk about the design that we had to do in order to make this project work.
All right, since the 2 bridges were elevated about 40 feet up the embankment slopes, there wasn't enough room to bring in any kind of fill. So we had to come up with a plan, through collaboration with the contractor, and we decided to go with driving H-piles, steel H-piles, approximately 70 feet to refusal. We braced in the lateral direction using angles as well, and made a rigid connection. All our connections were rigid, bolted. One, simplicity, but also to allow for the contractor to loosen the nut, put another plate in if they had to re-level. On top of that, we had 2 steel steel beams that we placed. One was a slide beam and one was a jacking beam. We built the superstructure, like Quentin said, on that. Concurrently, we had to make some modifications to the as-designed contract drawings, where we built a jacking block in the center of the proposed abutments that were built underneath the existing structure. And then we used that as a jacking block. So there was a conduit through the end diaphragms of the proposed bridges built on the temporary pile bins. We put an all-thread through the jacking block with a hollow jack on the outside plate with a nut on the end. As the stroke of the jack would push the bridge, it would essentially pull on the all-thread. So that's why there's a push-pull.
But you didn't really push the bridge into place.
It's an
you pulled
argument.
Yeah, essentially we pulled it into place, which was more accurate and produced less risk during that weekend.
Yeah. But we, before that, we had to jack up the bridge. We put a C-channel continuous to that jacking block, and then under each girder we put a Hillman roller. We went with that idea because it would be guided, and the simplistic approach that the contractor wanted to go with, what can go wrong will go wrong. So anything that any contingency we can come up with, we put a steel beam on the outside in the event that they had to reverse the slide. Like Quinn alluded to, anything that we could take out of that 55-hour window, we had to modify. When we did, they called for ultra high performance concrete to be backfilled up against once the bridges were slid in. We actually modified and put steel plates to block that out so the contractor could backfill with rock instead of the ultra high performance concrete to
And you-
eliminate that cure time.
And you've been getting a lot of public attention, public acclaim. You've been speaking at a number of professional societies. Your paper's been accepted for the International Bridge Conference. Tell us a bit about the public response.
Oh, absolutely. There's been a lot of interest. We've done the presentation at least 6 times. I think I have another 10 times or more to go. In March, Ryan is going to go with the contractor to present to PennDOT's project manager training, training tomorrow's leaders, managers, or something like that.
Training the client.
They're training the client.
That's pretty cool.
And it's been a good response. It's been very interesting. This is something that hasn't been done regularly in Pennsylvania, so to see it done in our backyard has been a lot of interest to a lot of people.
Very cool, very innovative, and congratulations again, guys, for a great project. And on behalf of LDG TV, it's a wrap.